So we're at Stickle Ghyll. We're at the original intake point of a redundant hydro scheme decommissioned when the valley was connected to the national grid. This previous scheme will have provided energy for the buildings at the foot of the Ghyll, the hotel, Stickle Barn, and also 2 or 3 of the cottages that are located down there as well. The beauty of this scheme is that we could almost replicate the existing penstock pipe route, possibly allowing the pipe, subject to planning approval, to go across the ground and thereby avoiding digging and disturbance to the ecology and the ground flora, and also potentially avoiding sediment entering the watercourse as well. Just to give you a little bit of background about the way that it could work here, we would look to have an intake point somewhere around here, possibly where the existing intake point is, and what you're effectively doing is creating a structure in which the water could flow over. Now you can engineer this so that you've got great big concrete structures in place which effectively act as very small dams, and the water flows over them. What the Trust is trying to do is to look for alternative ways to actually get this water into a pipe using less intrusive methods. The run-of-the-river systems are generally what we're looking at in the Lake District, where we simply abstract water as it's flowing over the intake structure. What then happens is the pipe, which you can see behind me there, is actually connected to that cavity, and that amount of water would flow down that pipe all the way down to a powerhouse near the pub. And effectively, with hydropower, the more head and pressure you get, the more power you can actually get from the system. We can also expand the size of the pipe so that we've got more water within it. That would also increase the amount of power that we could get from the scheme. So there are a number of different permutations that you can use with hydropower, but essentially there are 3 main components. There is the intake point where the water is taken from the main watercourse. The second part of the process then is the penstock pipe, which allows the water to transfer downhill separately from the watercourse, and then at the end of the pipe that's then connected to a turbine, and in essence what you have is a nozzle which squirts that water at paddles, and the paddles then turn what is effectively a propeller that is in effect then turning a generator. In terms of power generation, we're looking again at producing about 300 to 350,000 kilowatt hours of power per year. The other factor as well is the connection to the national grid. Some of the larger schemes just cannot be connected to the national grid within the park because of the fragility of the network, so we have to downsize accordingly. Some of the constraints at this site may well be ecology, may well be abstraction from the Environment Agency, but in all cases we need to ensure that we develop and stick to our ethos of developing sustainable hydro schemes.